Hello, so today I'm experimenting with GPT Engineer. So GPT Engineer uses the OpenAI API, and it's a tool to help you, to help you code. So we're going to see how much it can do. So we've got this code wars problem. So write a function which takes an array of numbers and returns the largest difference in indexes, such that data I is greater than or equal to data j. So the difference between 9 and 4 is 5, but we're ignoring that, right? We're only returning differences where, what data I is lesser than or equal to. Have they written this wrong? Well, maybe it's just backwards. But I think basically, okay, so we only compare them if they're ascending. Cool. So our output is just the difference, right? Yeah, so here we get 0. Well, actually, that's an odd edge case. Yeah. Cool, yeah. So this doesn't seem like a particularly difficult problem, but it's one that we can. So the first thing I'm going to try and do is see if we can get GPT Engineer to just implement the entire algorithm. And if not, what we'll do is I'll decide what functions I want, and I'll get GPT Engineer to implement them. So for GPT Engineer to work, there's a file called prompt. Unless they've changed it since I last used it, I did just update it. One moment, please. I'm just going to close my door. Okay, so where was I? So write a function. I mean, we could almost just paste this into so the way this is explained, I mean, even I find it hard to read, so see, why J and I? Is this some maths convention that I don't know about? Do J and I have some special meaning in maths? I'm just wondering why they've explained it like this. Well, let's try it the way that they've explained it and see what happens. Actually, before we do so, we will copy the tests if it lets us copy paste, which would be a miracle. Ah. So is this what our function's called? Oh. Cool, so let's see what GPT Engineer can do. So I think we need -I, which means it's modifying a project instead of making a new one. Initialize two local variables. Let's read its reasoning here. So I feel like it's implementing an algorithm which would make a lot of sense in an imperative language, but not a functional language. Cool. Do you want to execute the code? No, thank you. We can do that ourselves. Right. Well, before we answer that survey, let's just see what it's done. Cool. So load it into the REPL. So if we go back to our tests, let's just run one of these tests, but manually. Okay, so it hasn't quite worked, but that could be like an off by one error. So, I wish they would give more tests. All right, well, so yeah, what I want to find out now is, because that could very easily be an off by one error. So why is there? So the answer to this is 4 because. Wait, why would this be 4? Okay, so I clearly don't understand what this is even supposed to do, right? Because from what I understood, the answer would be at least 9, because this is bigger than that. And so what are we even trying to do here? I don't understand. Oh, we're returning the difference between the index of the data and the value of the data. Is that it? Ugh, this is kind of a silly problem. Okay, so we're returning the biggest difference between the index and the value. Okay, so index is 0 and value is 9. So index should be lesser than or equal to the value, but there it would be. I don't understand what we're even supposed to be doing. Oh, they explain it here. Consider all the pairs of numbers in the array where the first one is less than or equal to the second one. Okay, so for instance, this pair. Oh, find the pair where their positions in the array. Sorry, what? Well, this is a much more complicated problem than I thought. Consider all of the pairs of numbers where the first one is less than or equal to the second one. So would that include, say, 0 and 10? Or 1 and 3? Okay. I'm not really too keen on these problems where like understanding what you're trying to do is half the problem. Partly because there's no way I can explain this to GPT Engineer. You know, if even I can't understand it, then there's no way. Okay, so what we'll do instead, I'll design the solution, but I'll get GPT Engineer to actually write the code, as it were. And for each function that I want, I can write tests for the function. So I'll write the tests, and GPT Engineer will write the implementation. Okay, so let me get my head around what we're actually doing here. So do not sort it or change the order of the elements in any way. Why not? I mean, our output isn't going to be affected by whether or not we do this. So the tests that they're running isn't going to know whether we've sorted it or changed the order of the elements. So I guess this part is just a way of making it harder. But anyway, so consider all of the pairs of numbers. Yeah, but I still haven't got an answer to my question. So can a pair, what are the rules for the pairings? It doesn't actually explain that at all. It's a complete mystery. I can try and reverse engineer the answer from the tests. It doesn't explain what the pairings are. Can we pair up -1 with 10? If that were true, we wouldn't get this result. It doesn't make any sense. So here, so obviously 10 is bigger than 1. And the difference in indexes is 1, obviously. Wait, so can we pair 4 with 10? The difference in indexes. Okay, so my current understanding of what we're doing here. So we're finding pairs. And the pairs don't have to be next to each other, but the second number has to be both after the first number in ordering and also bigger, right? And then we find the difference. So in this case, the reason the answer is 4 is because 1, 2, 3, 4. These two 4s are okay, right? Because the logic is greater than or equal to. Okay, so at least I understand what we're even doing. Right. Yeah, this seems quite complicated. So that's actually why it's telling us not to sort it or change the order. Because that would actually change the problem. So how about we do it in 2 passes, right? So we loop through it. So the first step. So for each number, we find all of its pairings. We find all of its pairings. No, we don't need 2 passes. So what our function is going to do, well, it'll be a loop. So we can't use reduce for this because our function is going to need access to the entirety of the rest of the data structure. So it's going to be like a loop where it just discards the first element each time it goes through. Yeah, I think I know how to do this. Probably should have chosen an easier problem. So, what has GPT Engineer even done here? So it's defined some indexes, which is the entire size of the data array. So that seems like a sensible start. Okay, and then it's made a map of indexes to data. Is it indices? Is that a word? Yeah, I think what GPT Engineer has done is what I originally thought. So it's just pairing them up with whatever's next to each other. So the reason it gave an answer of 3, why did it give 3? No, wait, so how's it calculating the difference? Hmm? I will say this isn't very easy to read. So what's the first argument we're returning, right? So we're returning either that or that, right? So max diff will just be, okay, so oh, that's interesting. I didn't know Clojure had a max function. That might be handy. So this min index, where does that come from? Min index. I don't understand. It's not obvious to me what GPT Engineer is trying to do. Okay, well, let's ignore that, right? Because we know it doesn't work, so trying to reverse engineer what it's supposed to do is a waste of my time, so I'm going to delete this. Well, let's not delete it, let's just... Alright, anyway, so now we can make my own. I spent so long looking at that, I've forgotten what we're doing. Right, yeah, so we need to loop, so good enough, I guess. So we're going to be keeping track of that. And we're going to be keeping track of the biggest difference. So how do we know what our index is? Should we count our index as we go, or should we? I mean, what GPT Engineer did was it pre-calculated all its indices. But there's not really any reason to pre-calculate the indices. We can just calculate it as we go. Just because I'm just done. Anyway, cool. So okay. That is not how Clojure works. So value okay. Right, so what we need to do so we search through REST. No, we do need to pre-calculate our indices, otherwise it will be a pain in the ass. Yeah, so we can copy that from ChatGPT's solution. Or GPT Engineer. And then it mapped. Oops, then it mapped it, didn't it? That's stupid. So why are we doing this? We're mapping vector over it. Oh, I guess that's convenient. Okay, fine. So we've got a list of vectors basically. Fine. One moment, just opening the door. Where was I? Right. So we don't need this. Cool. Cool. So we just need to look at everything in rest and compare the values. So can't remember the order of things. Predicate collection, yeah, obviously. So, oops. Right, so so we need to test if things are bigger than is that how it works? I can't remember which is testing is bigger than which. Oh, no, plus. No, so that's wrong. So cool. So is it bigger than right? And then well, and then we can just sort that based on so that hang on, that max function we found. K being what? Let's look at closure. Yeah, so that we can have a function. Is that what we want? I forget what we're doing. Yeah, that's fine. So our function is first. Wait, so indices data, right? So hold on, this isn't right. Because when we call this data structure, so the second value is the data and the first is the indices. I mean, that shouldn't be called data, that should be called whatever. Anyway, so second, yep, and then we just do, well, let's test what we've done so far, right? Oh, except we can't run this. How can we get it into a state where we can test it? No, that confuses me. Let's just continue what we're doing. So no, that's not helpful. That just tells us the highest. Oh no, that is it. That tells us the highest index. So right. So we find everything with a higher number, Oh, it's supposed to be greater than or equal to, actually. And then we find the one with the biggest index. Cool. So what this is the biggest difference between this number. So for instance, let's say we're at 9. So first it filters it down, so we've just got, well, 10 in this case. Maybe 9 was a bad example. So let's say we start at 4. So it will filter it down to 10 and 4, because they're both greater than or equal to. And then of those, it will find the one with the highest index number. That's what we're doing so far. Cool. And then we recur. Right. So we recur with rest, and we can just do max again. So max of should we call them ultimate biggest and our biggest? So our biggest is the biggest for this iteration of the loop, and ultimate biggest is the biggest of all the loops together. Hold on, so what is this? So this is we're returning the difference in indices, are we? Yeah, we haven't actually calculated that yet. Wait, let's split this logic up a bit so it's easier to read. So we subtract from our index, which is what? So we subtract from our index. I don't know why, but today I can't remember what the order of the arguments is in anything. Cool, so we subtract. Wait, what? No, this is wrong. If we do that, we'll get a negative number. So this is our biggest difference in indexes, right? So we recur with the maximum of cool. So if I'm right, this should actually... Oh, I remember I was going to use GPT Engineer, wasn't I? Well, it failed, and honestly, explaining to GPT Engineer what to do would be... Anyway, I haven't tested it yet. I don't even know if it works. So let's see. Oh no, it won't work with it because I haven't... There's no logic to actually exit the loop. It'll just loop forever or something. And it's still in the wrong order. So if it's greater than... So if we haven't exhausted all of the elements, then we recur. Otherwise, we just... Oh. Otherwise, we just return. Okay. So let's see if this works. Okay, error. Ugh, I hate errors like this. Lazy sequence can't be cast to a number. It's so hard to debug this stuff. So does it give me a line number, line 10? Lazy sequence can't be cast to a number. So we're trying to do maths on something that isn't a number is essentially what it's saying. So can we just basically what I need to do is add some debugging code in the middle of this let, which isn't really what lets are for, but so what are we doing? So firstly, let's just check that that's giving us what we expect. Sorry, what? How can it be a that's very odd. How can this variable just be a parenthesis? That doesn't make any oh, because I need to convert this into a string. Line 9. I wish it wouldn't do this with the errors. Sorry, so line 9. Line 9? Why has the error moved to a different line? Persistent vector can't be cast to a number. But why has it moved up the line numbers? I haven't changed this line or anything above it. Is the line number wrong? I mean, it could be that it's just unhappy with what I've done here. Expected number received function. Oh, because I used the wrong thing. It's not supposed to be max, it's supposed to be max key. Is that it, max key? Yeah, max key. All right, I think my debugging code actually broke it of itself. Okay, so line 10, lazy seek cannot be cast to number. That's the original error. Okay, well, I do actually need a way of dissecting this and figuring out what the output of this is. So we are going to have to, since my attempt of debugging it by adding something inline didn't work, so we'll have to do some hacking around. How do we... That's not what I want. What did I just do? Right. So we're going to have to add another let. Right. Just so that we can find out what it's complaining about. So it's complaining about line 9, vector can't be cast to number. But why does the error keep moving? Why is the error moved? That doesn't make any sense. I haven't changed this line, nor have I changed anything above. And it never printed this, not even once, so we're on the first iteration of the loop. Okay, well that's bizarre, but okay, so what could be happening here that could be causing? So it's saying that we're comparing well, yeah, that is invalid because we're comparing line 11, lazy seek can't be cast to number. Right, so yeah, so we're getting a lazy seek out of this. I hate this thing where it gives you a lazy sequence. So what you're supposed to be able to do, although it doesn't always work, there's this function do all, and what it allegedly does, although it doesn't normally seem to work, is convert lazy sequences into actual. Yeah, it still doesn't work. Yeah, let's just convert it into a vector. It's the only thing that I've ever seen work. So it's a vector of vectors. Vector can't be cast to numbers. So why is it a vector of vectors? Don't do this. Oh my god. I really need to find a way to turn off these error pop-ups. Sorry, what? So why is our output 3 and 10? Because at index 3 we have 10 yet. That's fine. That's correct. Yeah, so that's fine. So why are we erroring on line 11? So so we find everything with a greater value. And that should be okay, right? That seems right to me. So there's only one item in this list. Yeah, which is correct. And that list then contains 2 numbers. So we take our list, we apply first. So what's wrong? So what happens when we do that? Yeah, that's fine. So why are we getting an error here? Vector can't be cast to number. Oh. Yeah, no, my bad. Yeah, we really shouldn't just be using first and second all over the place. Oh, it doesn't make things easier. Okay, I think I fixed it. Might want to refactor it to make it easier to read. Another error, lovely. So line 11 vector can't be... How can it be the same error? Did I not reload it? So you're still telling me vector can't be cast to number. Well, I fixed that, I don't get it. Okay. So let's just print out the 2 things that we're comparing. So we're comparing that to that. line 12. Cool, so what do we print out? So we're still getting a vector. Why would we be getting a vector? Huh? What? That doesn't make any sense to me. I would. So what's this max function actually doing? This max key function does not seem to do what I think it does. So we're giving it, I mean, this is what we're giving it. It's like it's just spitting back out what we've given it. Yeah, it is. How is it doing that? I don't get it. Oh, because I don't get it. So we're giving it a list. Wait, does max key expect multiple arguments? Do we need to do an apply to it? So what is max? How does max key work? Oh, so yeah, it doesn't expect to receive a list. It just expects to receive a whole bunch of inline arguments. So I need to do an apply to our max key. How did that happen? Cool, so okay. Having a lot of errors, aren't we? Line 10, wrong number of arguments passed to max key. So we've already looped through 1, 2, 3 times. Wrong number of arguments passed to max key. This isn't even valid code. I've just missed out a parenthesis. Wait, that doesn't seem right either. Wait, how did we end up with this code? Sorry, what? So max key applies first to each of the items. Yeah, we're going to need to. Do we have to do that? No, that's not right. How do? So hang on. So what does apply do in the case where? So if we give apply just a list, so I don't know, plus 4, and then we apply. So what happens then? Right, so how do we do this? So we apply. No, I don't see why we can't give max. I don't see why we can't give apply a lambda. But it'll have to be. We can't write it in that format, can we? Does that lambda shortcut? It's called a macro, isn't it? Does the lambda macro support creating a function with multiple arguments? That's the question. Why is Google so useless? Google hasn't returned anything pertinent to what I've searched for. Yeah. If you need a function with multiple arguments, you can do yeah, but yeah, okay. So it doesn't support that, fine. So Fn. I mean, how do we even? This hurts my brain. I'm really confusing myself here. I feel like this shouldn't be difficult. I thought I'd be able to just do this. I'm not sure why apply wasn't happy with that. Let's get rid of the changes I've just made so I can see what I'm working with. Right, so let's remind me what the problem was in the first place. So we just want to cram all of these into this expression. Okay. So can we not? I feel like this should have worked. What's the problem? Okay. I mean, we could solve this by pre-processing. No, this is stupid. What? Well, hang on, do we need, what information do we need to get out? Yeah, we can pre-process it. So we apply max to the result of mapping first over everything. And then we don't need this outer first. Cool, so let's just make sure that we're printing that out. Line 10, 0 arguments passed to max. Huh? I find that hard to believe. 0 arguments. Oh, that's because it's already cycled through everything, right? No, it's because Oh, no, that is a valid situation. Yeah, that can happen, right? So so how do we deal with that special case where there is nothing? So we can't apply max to nothing. Let's get rid of our debugging info, debugging as code. So this is, so we calculate the max and then we subtract. Right. Cool. Hmm. So list of indexes. Or indices or whatever they are. Okay. So if that's not 0, we do this, otherwise we return 0. Cool. So it doesn't like that we've got a let inside of that, but let's see what happens. Cool. That's giving us the correct result. Okay. I'm just going to take a short break and we'll finish off in a moment. Okay, so where did we get to? So we implemented the solution. So we've only tested it with, actually we haven't run the full suite of tests they gave us, have we? So let's just, so there is actually a keyboard shortcut to run the tests. Let me just remember what that is. Yeah, apparently if we press Control-C, Control-T, it'll run a test. So do we, I mean, I would assume we need to import the namespace, but let's try without. Yeah, so we do need to so the test worked. Run 2 assertions in one test function, 0 failures, 0 errors. Cool. So our function, so those 2 tests that they've given us are kind of insufficient. So I do want to do some more refactoring on this because I think it's well, it's quite obviously not written very nicely. Actually, let's just fix the most egregious problem right away, shall we? So Let's just test I didn't just break that. Cool. We've still got some random white space. The other thing we can fix, well, hang on, are we going to test it or not? Let's test it before we do any more improvements. So, it actually let us paste. It's a miracle. So let's just first do that. And then we do attempt and it runs the full batch of tests. Cool, so they're happy with it. So what tests did they do is the question. Oh, it doesn't tell us. It only tells you what the test is if you fail. Okay, but anyway, so we just try and tidy it up a bit. So we've got all these calls to second and first all over the place. It's not that bad actually. I mean, strictly speaking, this is inefficient because it's evaluating that every time, but no, I'm not sure it's worth fixing. No, I think we've done it. Cool. So let's submit it and then see what other people did. There's always someone who just does it with an incredibly small amount of code. It's so annoying. It just seems to be the way it is with these coding problems. Yeah, mine's like colossal. I mean, to be fair, it's partly perhaps. Anyway, what's this guy done? So he's got 10 upvotes for best practice. Okay, so he's used a function called map indexed. So I didn't know that such a function exists, but presumably what that does yeah, I get it. Yeah, so that's basically a shortcut for doing something that took us 2 lines in our solution. Why is the formatting so messed up? Ah, he's done it with 4. Yeah, because 4 can essentially do filtering. Yeah, well that's good. Compare with your solution. So I don't so much blame myself for this bit because obviously that was just a function that I didn't know about, that map indexed function. But this entire loop that I've made can just be done with 4. I do need to get good at this 4 thing. Python has something equivalent to this. I think Python actually calls it a lambda, confusingly. In most programming languages, a lambda is like an inline function. But in Python, a A Python lambda is where you do all this hackery to like rearrange and restructure data structures. These are all very minimal examples of, okay. Yeah, these are all very minimal examples, but I think these Python lambdas can do the same kind of thing that closures for does. But anyway, yeah, I'm going to need to learn more about for because it can clearly do some cool stuff. Anyway, in terms of actually demonstrating GPT Engineer, well, I mean, essentially it failed because it didn't understand the problem. Now, this wasn't the kind of problem where I could divide it up into functions and just get it to do the individual functions. So yeah, this is a good example where GPT Engineer isn't quite. Although to be fair, the information I gave it was just the the information I gave it was just the summary description. I didn't give it the long description. But yeah, anyway, I guess that's it. We solved the problem and we learned something. So that can be it then.